Hello, welcome back, Smart Contract Maxis. In the part two of our payment smart contracts. In the part one, we have written smart contracts. We build it from scratch and we followed some of the best security practices, and we also optimize our smart contracts. And in this video, we are going to test our smart contract and to check it is behaving as we expecting. And don't worry, I have written already more entire test, and I'm not going to do this live because it will be very long video. I will explain you every single line of this code, this test suits, all the test suits, and at the end of this video, we will write deploy script and we will deploy it on Rootstock test network. So let's recap what we have done in the part one. We have written this payment smart contract, which is ownable, and we have one is rent guard, and we are using safe ERC that is coming from Open Zeppelin smart contracts, and we have declared mapping here, we have events here, we have errors here, and we have a constructor, the function of a function to register tokens, function to pay ERC20 and pay native, and the claim payments, and get contract balance and batch register. So this is what we have done so far, and let's compile this forge build, and you can see here it is compiling, compiler run successfully, which means our smart contract is compiling successfully. And in this video we are going to test. So let me show you what we have done. So wait, what we let me show you what I have done to write some test. So inside the test directory I have created a mock directory, and inside that I have created the ERC20 smart contracts. So basically in the previous video I have showed you how you can create, build, test and deploy ERC20 smart contract inside the Foundry. So this is the ERC20 smart contract just for tested, and inside the test directory we have this payment test.t.sol, which is for the test, which is the test of our smart contract basically. So let me I have written entire test. You can see here, this is the huge test I have written. Don't worry, I will give you git repository, and I will explain right now here what I have done, and how you can do, how you can test as well. So this is the test. I will explain you every single line of code, and at the end I will even give you GitHub repository. So let's start. This is the Pragma Solidity, the 20 version we are using, and I have imported test from Forge standard library. This is the payment smart contract I am importing. This is the payment smart contract we have written in the previous video, and this is the mock ERC20, which is the mock ERC20 we are built, and this is the contract payment test is test, and we have declared some state variables here, and then we have some events here, you can see here, and setup function, and this is the setup function to set up the owner with ETH, and we are deploying contracts here, and we are deploying this to ERC20 smart contracts here and minting some ether here. So you can see initial balance here, and we have initial balance of 1000 ether. So this is the function setup when you are writing test in Solidity in Foundry. So you have to, this is mandatory function you have to write, and then we have this test register token, and there we have this expect emit. So I hope I guess you guess right that expect emit, which is related to events, which takes two parameters, and we are emitting event here, and after that we are register the token as a owner, and we are franking. So don't worry if you don't know this, where are this vm.frank and vm.expect coming from. So you can go to book.getfoundry.sh, and inside that you can go here the test, and test you can go inside the test cheat codes. There are some cheat codes here, I think. Yeah, I didn't connect it to internet. So yeah, let go back and refresh this again. Yeah, you can see here. So there are some cheat codes here. They are using this only. So we inside this function. Let's continue. Check if the token is whitelisted. We are checking if the token is whitelisted or not. And after that, we have this function of test batch registered tokens, and which is public. Let me tell you here, let me give you an insight here. When you are writing test in Foundry in Solidity, you have to start writing function with the test name. For example, you are testing ERC20. So always ERC20 function, always start your function name with test. That's it. And always make your function in public, because all the test cases you write in public. So after that, we have this function test register tokens, and we are trying to register token as a known owner. And we are using this vm.frank and vm.expect reward to register token as a non-owner. And after that, we have this test PERC20, and we are registering token, the logic we have written, and we are approving, and we are expecting to payment event to be emitted, and we are making payment here, and we are checking balance, and that's it, and so on and so on. And after that, we have function of test pay ERC20 tokens that is not whitelisted. And after that, we have the function pay ERC20 with zero amount. So we are trying, I have written entirely rigorous test here, and we are also pay test native. We also have pay native tokens with not token list, not whitelisted, and we are franking user here again and expect revert. This is not the prank you are thinking. This is the Foundry cheat code. So again, we have test of pay native zero amount, and we have written this logic here, you can see, and we have test claim payments ERC20, and also we have, this is the entire rigorous testing of our smart contract. So don't worry, if you, this is the first time you are seeing, I will provide you entire GitHub repository. So don't worry about code. And function test claim payments, we have also test claim payments not owner, and test claim payments insufficient balance. We have function test get contract balance to see if the contract balance is correctly we are getting. So that's it. We have written a long, like 263 lines of code of test. So let's run this command. If our tests are passing successfully, I running this org test, and you can see here our entire tests are fast. We have written 14 tests, and entire 14 tests. If you want to see coverage, you can run this command for coverage, and you can see here at the green. If you want to write more tests, you can clone this repo, and you can write more tests, and you can up this coverage, right? So you can see here currently the coverage lines, statement, branches, and functions. So let's clear this, and now without wasting a time, let's write a deploy script and deploy it on RSK test network. So let's go inside the, let's close this first, go inside the script directory, and let's create a file, deploy payment dot yes dot sol. This is deploy script we are going to write, and let's make it spdx identifier pragma solid 20, and let's first import script from for standard library, not for std slash script.sol, thanks to copilot. And now we have to deploy payment contract, so let's import payment contract, import payment from src. That's all. Let me check the path is right, src slash payment.sol, and that's it. And now let's contract deploy payment. Let's name it deploy payment main. Let's say it is going to be our script. Let's make it script, and yeah, now the mandatory function. In the past, in the previous videos, I showed you what we have to return. What we have to write is function run, and it should be external. Now we are using this pm dot start broadcast to broadcast transactions, and inside that we are going to deploy the contract. Let's say payment is equal to new payment, and that's it. And now we are registering token. So you can see here entire functions it is importing, it is inheriting entire functions that we have in our smart contract. So we are calling this function register token, and address of 0, and let's make it true. Let's format this document. By the way, if you want to format entire document, you can run this command forge fmt, and you can see here our entire this command your format your entire document, entire smart contracts, whether it's in test and src or deploy script. It will format your entire project's code, and it will beautify your code. And let's stop our broadcasting by running this pm dot stop broadcast. And yeah, let's console log payment contract deployed at payment.address thanks to Copilot, and we forgot to import console from our standard library, and that's it. I'm not going to use env file here. That's why I didn't declare extra variables here. So if you want to use private key stored inside your .env, I would not recommend as a professional smart contract developer. I would not recommend you to store your private key in .env as a mature developer. So if you want to still use, you can use your .env file, and here you can declare unt256, like you can declare a variable here like unt256, like deploy private key and blah blah blah, and like deploy private key, and it is like you can use the Foundry cheat code like vm dot env uint, and inside that you can create a env file, and you can pass this variable here as a private key, and you can use this inside the start broadcast. But I am not going to use this. So I have my Foundry gen wallet. In the previous video I showed you how you can create this one using this cast wallet and so on. So you can see here all the entire cheat code. You can use this cast. Foundry comes with four powerful components, that is arch, cast, anvil, and chisel. So you can use cast to add your private key and create a new wallet. You can use anvil to run your local blockchain. So you can see here using this cast command, and you can create new wallet and encrypt your private key. That's it. So without further ado, sorry, not without wasting time, let's go back to our foundry.toml file, and inside that we have to do some kind of configuration. As a first configuration, let's make it the Solidity version, Solidity compiler version of that we are actually using, not 17. We are using 20. Let's set up EVM version of London, EVM version of not Paris. It should be London, because we are going to deploy it on RSK test network, and here we are putting here our RPC endpoints. Let's declare this RPC endpoints, and we are going to use, and this is the RPC test point I am going to use, https://public-node.testnet.rsk.co. So you can use yours as well. You can go here, and you can use Alchemy or whatever the provider you want to use. You can go here and you can search on Google RPC Rootstock RPC URL, and you will get this one. By the way, you can add Rootstock mainnet and testnet to your MetaMask as well from here. And I think, yeah, this is how you can configure your wallet as well, and you'll get RPC from here as well. So this is the RPC URL I am using, public https public dash node testnet.rs.co. This is the chain ID trbtc. So this is also mainnet RPC URL here, and you can use this guide to set up your MetaMask as well. And so let's go back, clear it, and let's start deploying our smart contract. I already have wallet in my Foundry. So let's in my Foundry keygen wallet or script. You have to run this command for script. Inside the script, we have deploy payment dot sol. Inside that, what contract we have the same contract payment dot address. What we have done, this look like our Foundry. What is the member address not found is visible after argument contract payment. Let's start deploying. This seems like before deploying, I think, yeah, payment, and let's pass RPC URL as this RSK testnet and dash dash. Let's copy my address from here, not this one. I'm copying my address. I just count and hit the enter. we forgot to add the logic here. That's we did something wrong here. Yeah, what we have to do is address. I will show you how to debug this one as well. What we have to do is this is what I was doing. Address, and inside the address we have to. This is some chat GPT mistake. Inside the address we have to pass the payment. Let's format it and let's redeploy it. Now you can see here the compiling successfully and detected artifacts built from source file that no longer exists. Red flash screen to make, and you can see here our payment deployed at failed to get EIP 1559 fees. This dash because we have to pass dash dash legacy along with our smart contract. So let's pass legacy as well dash dash. We are already broadcast. Now hit the command and you can see here now this time we are going to deploy if everything is in our favor or we have done everything in right way. So you can see here setting up one EVM and you can see chain ID is 31 estimated and it is asking my password. I'm going to give here my password and hit the return or enter in Windows and you can see here. So before that I forgot to tell you, make sure you have some faucets in your wallet. So I will show you. You can go here, faucet.rootstock.io, copy your address from MetaMask and paste it here. Here you will get faucets. Check it. I'm not robot. Yeah, indeed, I am not robot here. Get test RBTC and they will send you some RBTC. So before deploying, make sure you have enough faucets or the testnet tokens in your wallet. So I have 0.03, that's are enough. So you can wait here for 30 or more than 30 seconds, but it will reflect once you get some faucets, it will reflect here the balance inside your MetaMask. Let's go back and you can see here our smart contract is indeed deployed on the Rootstock test network. So let's go back and copy the contract address. So you can see here entire information, how much gas, what is the block number, how much gas you paid for this transaction. And let's go back payment deployed at copy this address and go back to Rootstock Explorer, explorer.testnet.rootstock.io. By the way, they have upgraded v3 Rootstock Explorer. That is great. You can see here this is the beautiful UI and more information now here. Don't forget to give them send them feedback. The Rootstock team is one of the chartest and the best team and they have upgraded this Explorer with some beautiful UI. Let's copy here our contract address and let's check our contract status. It is indeed deployed or not. Yeah, you can see here. Let's click it from here and you can see here contract details, timestamp 2 minutes ago. It's 12 May and the timestamp total supply because we didn't have any total supply and the blocks, the hash and status is success. That time and from this is the same address. Let's copy it from here. Let me show you this is the same address and you can see here this is the B9, the same address I have deployed it from, and 2 this is the contract address E97 97 and there is no transaction of RBTC or any TRBTC we have made and this is the gas we have used. So that's it. If you have any question, please feel free to drop in the comments or the feel free to ask in Rootstock Telegram channel. They have 24 and 7 hours of support, 24 and 7 days of support, and also you can also ping some. You can also ask in a Discord channel as well. So you can, if you go here inside the rootstock.io, you can find all both of the links. You can connect them and follow them on Twitter, and here is the Telegram channel, the GitHub for open source contribution, and the Discord to join, and you can ask whatever the questions you have. I will give you entire code of this smart contract in the description of this video, and that's it. If you want to build more and dive deep into docs, you can find the entire documentation. They have really great documentation to build. This is the documentation they have. If you want to join community of ambassador program or upcoming events, you can read their blogs and you can explore the RBTC and its ecosystem, the supported wallets, and the RBTC roadmap. Also, they have really fascinating concept of OPEG and merge mining. So you can read about this from here as well. You can best thing is you can connect your wallet from here. So adding Rootstock, RBTC, and RIF to your wallet. So these are the two tokens you can see here, and mainnet, Rootstock mainnet. I have this, so it is adding from right from here. I have already added. If you want to have, if you want faucets, so you can see here successfully sent. So you can go to faucet.rootstock.io and you can see the successful transaction. So you go here. If you go here on the block explorer, they have indeed 4 minutes ago successfully sent us some test tokens, and you can see here on the testnet, Rootstock testnet. Now I have in the activity, not here. It is actually I have, it is reflected here. So how many tokens from this address to this address, gas price input, and you can see entire internal transaction details here and the logs. So this is the amount of 500 TRBTC we have received to test. That's more than enough to deploy many contracts. So with that, I'm ending this video. If you have any questions, please make sure to uh, join Discord and ask there, and I will see you in next one. Thanks for watching.